Alright, in this video I'm going to be going over the basics of a linked list. I'm going to show you how to set up the code to get started on one, and then we'll also look at an illustration to try to better understand exactly what a linked list is. The linked list can be a little bit confusing at first. It was for me when I first learned it, so don't get discouraged if you're confused. If you don't understand it after watching the video, feel free to look at other videos. So you may want to use a linked list anytime you're writing a program where you're going to have a list of objects. So you've got a structure or a class for something such as a user, maybe in a chat program like Discord, or maybe in a video game you've got a list of enemies or a list of objects. All of these users or objects have to be updated. You may need to get input from all of them. You may need to send output to all of them. And so essentially you need a list of those objects. The thing is, sometimes objects need to be added to the list or they may need to be removed. And so here's where a linked list comes in handy and can do things that an array cannot. The first thing we're going to have here is a structure for our objects, and I'm just going to call that node. I'm going to put a string in here and I'm going to call that name. Now we can have as much data in here as we want, but to keep this simple, each node is only going to have a name. And then we're going to put a pointer in here that points to a node, and this will be the next node in the list. So I'll just call that next. And that's it. That's all we're going to have for our structure here. I'm going to go down to main, and I'm going to create a few nodes, N1, N2, N3. And I'm not going to bother with the name for the moment. I'm going to work on setting these guys up so that they are actually linked together in a list. So we would say N1.next is equal to, now next is a node pointer, so it has to be equal to the address of some other node. And if I want to chain N1 to N2, then I can say it is equal to the address of N2. And that will connect those two nodes together. And I can do the same thing with N2. If I want to chain N2 to N3, I will say N2.next equals the address of N3. And now these guys are all connected. N3 doesn't need to be connected to anything. If you wanted to bring your list full circle, you could say N3 equals the address of N1, but that's not typically how you would do things. We would just have N1 at the front, and we have N3 at the back. N1 is called the head, and N3 is called the tail. And you can put as many nodes as you want in a list, but we'll just start with 3 to keep it simple. So here's a little illustration of what the objects look like. I've got the same code here, and now I'm going to draw boxes for each one of my objects. So these are all nodes from my node structure up here. Remember, the structure itself is not an object. It is just the blueprints for the objects. And we can create as many objects as we want from that blueprint. So you can kind of think of it like Legos. These are the instructions, and these are the objects we actually create with the Legos. Each one's going to have a name up here, N1, N2, and N3. Each one also has an address. Now I just put some numbers in there. I said this was at address 100, 300, and address 450. The operating system decides what address your nodes get, so don't worry too much about that. Each one has a name based on the structure up here, and each one will also have a next pointer inside the object. And like I said, each one will be connected. N1 will connect N2, and N2 will connect N3. And so because in this little illustration, N2 has an address of 300, N1's next is equal to that 300. N2's next is going to be equal to 450. And so that is how they are chained together. The last node is called the tail, and it always has a next pointer that points at null. And that's kind of how you know it is the last node on the chain. So we just set that last one equal to null pointer. I didn't do that in the code yet, but as we continue here, we will do that. Sometimes it can be best just to set this to null pointer right from the beginning. And that way, if it isn't set to something else, it is effectively null. So N1 is going to be the head, N3 is going to be the tail, and you will also have pointers with the linked list that are called head and tail, and each one will point to the first and the last node in the chain. So that looks kind of like this. There's my head pointer, and there's my tail pointer, and each node points at the next node with the last one here pointing at null. So there's a little illustration of what the code looks like if you think about the objects in the memory. They're all separate objects. They could be anywhere, but they are all connected through these next pointers and each one's address. So this is just manually connecting a few nodes. If we're going to use a linked list effectively, we're going to need a class for it, and we'll want to add nodes as we want and remove them as often as necessary. So you can think again of users on a server coming and going. That's a pretty dynamic operation, so hard coding them like this is not very effective. So to set this up, I'm going to create a linked list class linked list. And the linked list is going to have those pointers I just talked about. So we'll have a node pointer for the head, a node pointer for the tail, and eventually we're going to need another pointer called current. So if you were updating all of the nodes on your list, whichever one you're working on at that time is the current node. We'll also set all of these guys equal to null for the moment. And that's a good start for our linked list. Now we're going to need a few functions. The first one is going to be add front. If we want to add a node to the front of our list, we will use this function. We'll also need to know the name of this node. So we're going to fill in this data right here. We'll have the user pass that in, or the programmer I should say, pass that in. And the first thing we want to do if we're adding a node to the front is create a new node. So node pointer node equals new node. And then we'll set our node's name based on the name that was passed in. So node name equals the name. And now we need to add it to the front of our list, meaning the head is going to change. If we're adding something to the front, the current head is no longer going to be the head. It will just be the second node. And our new node here will be the head. So to make those changes, the first thing we're going to do is connect this node to the current head. So nodes next equals head. But what if there is no head? So we've got to think about that. If there is no list yet, if we don't have a head, this will not work. This will just crash. So we'll put in an if statement there. If the head does not equal null, current node next equals the head. The next thing we need to do is change the head pointer to our new node. So we will say head equals node. And that adds node to the front of our list. And then it moves our head pointer to the new node. That's pretty simple. What if the head is null pointer though? So in other words, we have no list. We will say else head equals node. And if we have no head, we also have no tail. So it's important to say that tail equals node. If there's only one object on the list, the head and the tail are the same node. So we will set both of those pointers accordingly. Now to test this function out, we will also need a display function. So let's write that. say void display. We don't need to pass anything into display. We just need to roll through our list and display everything. I'm going to use my current pointer. I'm going to move it along through the chain until we get to the end. So to do that, we will say current equals head. That way we start at the beginning. And we will say while current does not equal null, cout current's name. And that will display the name of that node. And then we will move our current pointer over to the next node in the chain. So current equals current next. And then we'll just hop along through the chain all the way to the end. And then when it does hit null, we will be finished with our display statement. All right, to try this out, I need to go down here and create a linked list. Now we'll just call it list. And this is going to be a little bit of a problem because I forgot to make my class public. So we'll come up here and make everything public. And then I will say list.add front. And we'll just add a few names to this list. So we'll add Fred. And we'll add Mary. And then we'll add Joe. And then to see if my linked list is working correctly, I will say list.display. And I should see all three of these names. So let's run that. And it works just fine. So with this setup, we should be able to add nodes to our list indefinitely. And this only works for adding them to the front. We will want to add a function that adds them to the back, and we will need a function that searches through the list, finds a node, and removes it. So let's say void add back. This one will be similar to add front. We're going to have a name that is passed in. We're going to check and see if the head is null, and if it is, we'll have one condition where we set it up, and then we'll have another condition where we set it up if it's not null. And then we also need a remove. So to remove something, we need to know which one we're removing. So that will be passed in right there. In this function, you're going to have a loop similar to our display down here, where you're going to iterate through the list and you're looking for this name. So if any node in the chain has that name, you want to remove it. When you remove it, you have to repair the list. So the node that is pointing at the node you want to remove has to be connected to the node that is in front of the node you're removing. If that's not confusing enough, I'll show you what that looks like. If in our illustration here, if we wanted to remove node 2, it would look something like that. But now our chain is broken. And so this pointer here can no longer be pointing at 300. It has to be connected to the next node in the chain, which in this case is going to be 450. So in order to fix it, we want this connection here. So I have to change next. Next is going to be equal to 450. And how do you get that 450? Before we delete this node, you have to say next equals next. And that will bridge the connection, and then you can remove the node in the middle. And so after we've removed it, it should look something like that. And that's with any case. When you remove a node, you also need to make sure you're not removing the head. If you remove the head, you have to move your head pointer over to the next one. Same thing with the tail. If you remove the tail has to be set to the new tail on the list.